Every time you type a website into your phone, a question gets asked first, silently. What is the address for this name? For decades, your internet provider could simply read that question as it went by. That question happens constantly, hundreds of times a day, for every site, every app, every background service your phone talks to. And the old protocol sent it in plain text. No lock, no envelope, readable by any device sitting between your phone and the answer. Which meant your ISP could quietly build a complete log of every domain you ever visited, not the content of the page, but the trail of everywhere you went. DNS over HTTPS, often shortened to DoH, was built to close exactly this gap. Take the same question and seal it inside an encrypted HTTPS connection. Once sealed, that query looks to anyone watching the wire identical to ordinary secure web traffic, indistinguishable by design. The result, your ISP still sees a connection but not what's asked inside it. The question itself disappears from view. A readable question, quietly logged for years, replaced by a sealed envelope only one party can open. Let's follow one lookup through both worlds in slow motion. Take one the old way. Your phone wants to reach a website, so first it sends a DNS query out to a resolver, often one run by your own internet provider. That query travels as plain text over an ordinary, unencrypted connection. Anyone able to observe that link, the ISP, a shared network, a curious middle box, can simply read it. It says quite literally which domain your phone is about to visit. No scrambling, no lock, just text sitting in a packet. Multiply that one query by every site you visit every day for years, and your ISP is sitting on a detailed timeline of your online life, without ever opening a single page you looked at. That log doesn't need the page content to be valuable. Domain names alone reveal an enormous amount: your bank, your health provider, your search habits, your politics. Now take two. DNS over HTTPS keeps the same underlying question, what's the address for this name, but changes how it travels entirely. Instead of a bare, unencrypted request, the phone opens a standard HTTPS connection to a DoH-capable resolver and sends the query as part of that secure session. That secure session wraps the query inside the same encryption scheme your browser already uses for secure websites, the padlock you already trust every day. Before any data flows, the resolver proves its identity with a certificate, the same mechanism a bank's website uses to prove it really is the bank. With that identity confirmed, the query rides inside the encrypted tunnel. From the outside, this connection is visually identical to checking your email or loading any secure site. Your ISP now sees the same thing it sees for millions of other HTTPS connections, an encrypted stream to some server at some port. The domain being looked up is gone from view. That single change is the entire trick. Not a stronger lock on the old envelope, but swapping the envelope for one nobody outside the conversation can open. But hiding the question from your ISP doesn't make it vanish, it moves. Whichever resolver you configured now becomes the one party that can still read every lookup you make. This is the trade at the center of DoH. You're not eliminating trust, you're relocating it. Choosing a resolver becomes as meaningful a decision as choosing an ISP once was. There's also a limit worth knowing. Even with DoH turned on, the server name your browser connects to can still leak in a separate step of the connection setup, unless a further protection is also enabled. That remaining leak has its own fix called Encrypted Client Hello, which seals that last visible field too. DoH and that protection are usually deployed together for full coverage. Some networks, schools, workplaces, some countries actively block DoH traffic specifically because it removes their visibility, which tells you exactly how much that visibility was worth to them. Plain text once meant your ISP could read every address you asked for, logged quietly for years. DNS over HTTPS seals that same question inside ordinary encrypted traffic, moving trust from your ISP to whichever resolver you choose. Now you know, next time your browser loads a page instantly and privately, you'll know a sealed envelope, not a stronger lock, made the difference. Check out our other videos and follow how it all runs for more. Catch you in the next one.